if you superimpose all these river grid systems, and this is how this land mass is ravaged by these river flows. So as the gradient changed, the river flow changed, and you had old river flow systems replaced by new river flow systems as the continental plates decided. Now, moment you take a look at this grid, you feel like, is there any way we want to exploit this situation? But one may ask, why exploit in the first place? As I said, if at all the reasons are more conducive for this exploitation, they exist on India landmass. That is possibly because of the glacial nature of the northern rivers that flow in northern India. Whenever there are monsoons, the northern rivers usually flood the landmass. And such is not the case with the southern rivers, possibly because absence of the glacial connection. So the southern part of India is always struggling with less than required water. So obviously the Indian administration would have wanted to solve two problems with one solution, which is, if there is any way you could exploit, if you could redistribute the excess river or excess water from the northern part to the southern part, then everyone would be happy. And this is not just a concept, it is a project which is ongoing in India. It is known as River Interlinking. And this is how the River Interlinking looks like. What you see as blue is all Himalayan sector. And the one which you look at as red is the peninsular sector. Now you can see the number 10, which is Ken Betwa. It is such a small project, and this project is going to cost India 46,000 Indian rupees, 46,000 crore Indian rupees. And if you put up the entire project value, that is around 5,60,000 crores of Indian rupees. That works out to around 70 billion US dollars. That could be as much as 2% of the GDP of India itself. And how these projects are susceptible for inflation over a period of time, would not be surprised if it gets doubled. So if at all, if you could exploit this ancient river flow systems, you do not have to do the river interlinking by digging up the whole canals, concreting them and controlling the river flow. You could just use these grids and redirect the water. But it's easier said than done. The major problem is the river flow systems, which is shown beautifully now as grid. If it is true, if this is how the river flow system is on this landmass, why do we not see these whenever there is a rainfall? They should be following these river flow systems also. Even if the gradient is other way around, the river flow system can flow in the opposite direction. But that is not the case. Why? The grid that you see is a top view when you're looking at the landmass from the top, but they are not in the same level. The current flow system obviously is on ground level 0, but the ancient ground level systems are below it, because geological forces have these, over a period of millions of years, that they keep adding the deposit layer by layer, and obviously what is 180 million years ago will not be on the top. So you have the current flow river system at G is equal to 0. The ancient river flow systems would be much below, and the previous one would be even below from that. So this is the major challenge, and we will see how we can make use of how we can solve that problem. But even before that, there are many more, how should we say, pros and cons. Pros, obviously, we know if at all you can exploit, if at all there are ancient river flow systems that you can exploit, it will be cheaper, faster, quicker, environmentally friendly. The benefits are many, many. But there are, just the way there are pros, there are cons also. So we study those cons one by one, and then we come to the level problem at the last, and we will try to solve that also. But it is easier said than done. The challenges are one too many. So let's take the first one. We are talking about these timelines, which is 4 billion years, 180 million years, 50 million years, assuming that the rain cycle is still there. What if 180 million years ago the rain cycle was not there? Fine, tectonic plate movements are there, the mountains are formed, the gradient is formed, but there is no water to flow. No water, no rain cycle, no river flow system. So let us see. The basic part for you to have a rain cycle is water. We possibly do not know exactly where water came from, whether it was brought in from asteroids or water was all along there on planet Earth. But for sure, the age of the water that is there on planet Earth is as old as planet Earth itself. So water has been there possibly in larger quantity than it is now. So when you have water in such quantity on the surface, obviously the seas were there. When the sea was there, and we know for sure the for evaporation to have happen, you have to have a heat source, and the primary heat source is our own star, sun, and it's been there even before planet Earth was formed. So we have had, how should we say, seas evaporating. So planet Earth has been blessed with, how should we say, a blanket of atmosphere which is basically a vaporized water. But it does not help you to have just an atmosphere. You need that atmosphere to move. And thankfully, the way the planet Earth is shaped, the equator receives more heat as compared to the Arctic polar circles. So obviously there is a temperature difference. Wherever there is temperature difference, pressure PV is equal to RT is a function of temperature. So the pressure difference is there. So when there is pressure difference, fluid, both the seawater as well as the atmosphere, moves from one place to the other. So obviously when it moves from the seas, the evaporated water in the form of clouds, when it reaches land masses, it condenses and rain cycle will take place. So that means the rain cycle possibly has been there all along the age of the planet Earth. So we do not have to worry about this. So we have taken care of first one.